Hello everyone. What if I tell you that a complicated expression with cubes and products can be simplified just by observation? Sounds surprising, right? Let's check how can this be done. We are given the condition that A by C is in continued proportion, and thus we need to prove that this expression is equal to 1. In the question, it is given that A, B, and C are in continued proportion. So it can be written that B square is equal to AC. And in the prove that statement, you observe the numerator and denominator carefully. We notice cubic terms in both the numerator and denominator. So now think of rearranging all the terms in one single cubic form so that ultimately the numerator and denominator both can be cancelled and then we get the value as 1. For example, check in numerator you have ABC and A plus B plus C the whole cube. Now A and C can be replaced by B square and thus you land up with B cube. So ultimately you can combine this B into A plus B plus C the whole cube. Let's look into the step-by-step solution. Since A, B and C are in continued proportion, so we can write that B square is equal to AC. Now write the proof that part as an LHS. Here, wherever you observe AC, replace it with B square. So in numerator, you get to see AC. So we replace that with B square. Also, you have CA, which is nothing but again AC, and even that can be replaced by B square. Now, once come to the numerator, you can combine these two terms and you can write B cube. Also, in the denominator, you see B as common. So that can be taken as common and to the whole cube. Now again you observe that in numerator you can take the cubic expression as common and this is where you land up with. And here both the numerator and denominator are found to be equal and obviously not equal to 0. That is our assumption. And that is where you can put as 1 cube and ultimately you land up with RHS. And hence we have been able to prove the final result.